Hello everyone. Today we're going to work on what we would call binomial radical expressions, okay, which means that all of our radicals are going to be in binomial form. Okay, so let's take a look at what I mean by that. When I say binomial radical expressions, we have to remember that binomial is two terms. Okay, so remember that means it's a polynomial that contains two terms. So we usually see this as like x plus y or 3x minus 2z, things along that lines, and we would work with that. For our radicals, we're going to be looking at something like 1 plus the square root of 6, or the square root of 2 minus the square root of 3. Okay, so we have to think of this as a binomial. It's two terms separated by an adding and subtracting sign, and it just happens to involve radicals instead of variables. So when we're working with these, when we're going to multiply, we're basically going to use our split distribute box multiplication FOIL method. Okay, so some of us learn it as FOIL, some of us learn it as split distribute. Some of us like the box method. Whatever method you use to multiply two binomials, that's the method you're going to use. Okay, so remembering that when you multiply radicals, they have to have the same radical, but they can be different numbers underneath, and we're going to multiply those numbers together. So let's take a look at this first one. So I'm going to do split distribute, which means I'm going to take 1 times 2 minus the square root of 5, and then negative square root of 5 times 2 minus the square root of 5. Okay, so I'm going to distribute the 1, so that's 2 minus the square root of 5. Then I'm going to distribute the negative square root of 5. Now remember, 2 and square root of 5s are two different types of numbers, so it's just going to be negative 2 square roots of 5. And then negative square root of 5 times negative square root of 5 is a positive square root of 25, because they're both like radicals. They both have the same square root, so I'm allowed to multiply the numbers underneath, or what we refer to as the radicand. Okay, so now we're going to simplify. So 2, and then I can add these two together because they're like radicals. They have the same numbers underneath, and all we're going to do is add the coefficients. So negative 3 square roots of 5. And then remember that we can take the square root of 25, and he's 5. So we're going to be, again, add like terms again. So 2 and the 5 becomes 7 minus 3 square roots of 5. And that's all you can do. Okay, please don't add the 7 and the 3. The 7 doesn't have a square root of 5. They're not alike, so we cannot add them together. All right, let's try this one. Okay, so again, this time I'm going to use the box method for those of us who use that. Okay, so some of us do use this, some of us do not. It just depends. Move it down a little bit. All right, so I'm going to put 2 and positive square root of 3 here, and 7 and positive square root of 3 here. So I'm going to multiply like diagonally, so 2 and 7 give me 14. 7 and the square root of 3 give me positive 7 square roots of 3. 2 and square roots of 3, so that's 2 square roots of 3. And then square root of 3 and the square root of 3 give me positive square root of 9. Okay. So now I have 14. And keep in mind that these two are like, so I can add those together. So that's a positive 9 square roots of 3. And then plus the square root of 9. Okay, square root of 9 is 3, so we have 14 plus 9 square roots of 3 plus 3. Add your like terms. We're going to get 17 plus 9 square roots of 3. All right, try the next two. Pause the video. Try the next two, and then we'll check our answers. Okay, so here are the answers to 3 and 4. So I used split distribute or FOIL method here. And I got negative 38 plus 7 square roots of 10. Nope, I did bad math there. So this should be 8 square roots of 10. I don't know why I made that 2. Okay. So this should be 10 7 square roots of 10. Apologize for that, guys. And over here, notice that these guys were exactly the same, but opposite signs in the middle. So our middle term here, these two guys, canceled each other out. Okay, so that happens every once in a while, and these are a special case. And if you remember, these guys, we gave them a name. They were called the conjugate. Okay. All right, so when we divide, we're going to use that conjugate idea. So if you remember, we used the conjugate in the past. Okay, so remember the conjugate are binomial expressions with exactly the same terms but opposite middle signs. We used the conjugate concept when we talked about I and not having the square root of I or I on the bottom of the fraction. So we're going to use that idea again. So we're going to look at our denominators and determine what the conjugate would be, and we're going to multiply top and bottom by him. All right, so let's take a look at this first example. Our conjugate would be exactly the same thing as the denominator here. So again, we're only looking at the denominators. Numerator's not going to get any love. And we're going to multiply top and bottom by exactly the same numbers or terms, but they're going to have the opposite sign. So we're going to do plus. And remember, top and bottom get exactly the same thing because we're making an equivalent fraction. So in this problem, we're going to distribute the 3 square roots of 2 in the numerator. So let's multiply that. So we're going to get 3 square roots of 6 because we can multiply the square root of 2 and the square root of 3 plus 12 square roots of 2. Again, you can't multiply the 4 and the 2 because the 4 is an integer and the 2 is irrational. On the denominator, we're going to do split distributor box. Okay, so I'm going to, or FOIL. So I'm going to get the square root of 9 plus 4 square roots of 3 minus 4 square roots of 3 minus 16. Now, when you're multiplying these and you don't get the exact same thing in the middle with opposite signs, you don't have the right conjugate or you did bad math. So keep that in mind. Okay, so now we're going to simplify. So simplify the numerator. There's not much we can do. We can't do anything, and we can't simplify the square root of 6. So we get 3 square roots of 6 plus 12 square roots of 2. In our denominator, we're going to be able to take the square root of 9, and our 4 square roots of 3's are going to cancel each other out, so they're gone. So now we have 3 minus 16. Okay, so let's clean it up one more time. It's 3 square roots of 6 plus 12 square roots of 2 all over negative 13. And that's as far as we can go because 3, 12, and 13 don't have any common factors. All right, let's try it again because I think we need a couple of examples for this. So let's try this one. So our denominator is square root of 5 minus the square root of 2. Okay, so we're going to want to multiply top and bottom by the conjugate. Square root of 5 plus the square root of 2. Okay, now we're going to have to FOIL, split distributive box, both the numerator and denominator. Okay, so we're going to do 3 square roots of 5 plus 3 square roots of 2 minus the square root of 50 minus the square root of 20 all over the square root of 25 minus the square root of 10 plus the square root of 10 minus the square root of 4. All right, so now we're going to have to simplify the numerator. So if we have 3 square roots of 5, there's nothing we can do there. 3 square roots of 2, again, there's nothing we can do there. the square root of 50. Okay, so if I come up here, 50, break it down, 5 and 10. 10 is 5 and 2. So we get the square root of 25, square root of 2, 5 square roots of 2. Okay, so let's put that in our expression here. So 3 square roots of 5 plus 3 square roots of 2. Again, we can't do anything with him. Square root of 2. Right? Minus 5 square roots of 2. We might be able to do something there. And then square root of 20. Again, we're going to want to take 20, break him down. Okay, so we get the square root of 4, square root of 5, or 2 square roots of 5. Okay, so let's put him in our expression. So minus 2 square roots of 5. Okay, it looks like we're going to be able to add and subtract some things in our numerator. Our denominator, again, the square root of 10 is going to cancel out because one's positive, one's negative. Simplify, we get 5 minus 2. Okay, so let's keep simplifying. Let's go simplify that numerator. So we have 3 square roots of 5 minus 2 square roots of 5 gives me 1 square roots of 5. You don't have to write the 1. And then 3 square roots of 2 minus 5 square roots of 2. So that's negative 2 square roots of 2. All over 5 minus 2, which gives you 3. So there's nothing we can do with that. Again, 1, 2, and 3 don't have any common factors. All right, let's do one more together. All right, so our denominator is square root of 7 plus the square root of 2. Again, our conjugate would be 7 minus the square root of 7 minus the square root of 2. Okay, multiply across. Again, do your FOIL, Fox method, whatever one makes most sense to you. Okay, minus 2 square roots of 2. 7 times 14, I believe that's 98. Yes. Plus the square root of 98 minus the square root of 28. Okay, all over. Okay, so we're going to get the square root of 49 minus the square root of 14 plus the square root of 14 minus the square root of 4. Okay, all right, let's go this way so we can see. All right, so we have 2 square roots of 7 minus 2 square roots of 2. All right, we got to do that 98. Let's put him over here, simplify him down. Okay. Well, we got there by doing 7 times 14, so let's use them. Oh, we have a pair. Here's my 7s. So square root of 49, square root of 2. So we get 7 square roots of 2 for 98. So plus 7 square roots of 2. Okay, let's do 28. Again, we're going to have to do him on the side. We got him by doing 2 times 14. Oh, I see a pair of 2s. Okay. So that gives us square root of 4, square root of 7. So 2 square roots of 7. Okay, so we're going to add him here, minus 2 square roots of 7. Now in these two problems that we're doing, we're going to be able to simplify. That doesn't always happen. All right, so let's see what we can do here. And the denominator would be 7. Our 14s cancel out. So that gives us 7 minus 2. So that's going to give me a 5 on the bottom. Okay, so let's simplify the numerator. 2 square roots of 7. Oh, look at that. Okay, so that goes to 0. These actually cancel each other out right here. So then we have negative 2 square roots of 2 and positive 7 square roots of 2. So that's going to give me 5 square roots of 2 over negative 5. All right, so now we can see we have a 5 and a negative 5. Both are integers. So we're going to be able to simplify that to negative 1 square roots of 2. Now, it doesn't always happen. It just works out that way. I want you to pause the video and try the next one on your own. All right, so let's take a look and see if you got the same answer as I did. So our conjugate would be 1 plus the square root of 2, both numerator and denominator. FOIL. Okay, so I got 4 plus 4 square roots of 2 plus 2 square roots of 10 plus 2 square roots of 20 over 1 plus the square root of 2 minus the square root of 2 minus the square root of 4. All right, so I simplified the square root of 20 to 4 square roots of 5. 4 square roots of 2, 2 square roots of 10, 4 square roots of 5. Nothing can be combined. There are no like terms. And then in the denominator, our square root of 2's cancel out. And I'm left with 1 minus the square root of 2, which is negative 1. Now, we can basically divide each one of those by negative 1, and that's where we get negative 4, negative square roots of 2, minus 2 square roots of 10, minus 4 square roots of 5. All right, hopefully, if you have any questions, please send me an email. Please check your homework when I send it back to you. That way you can check your work, and the answer key will be in homework next week. All right, have a great day, guys. Stay safe by staying in.